Hello friends, myself Sunil Goswami and this is second lecture of Unit 1 Solid State. In last lecture we were discussing about type of solids that are crystalline and amorphous solids. We discussed about their arrangement and now we will start from that point onwards. So today we will discuss about difference between crystalline and amorphous solids. So normally crystalline solids have sharp melting points. On the other hand, amorphous solids soften over the range of temperature and can be molded and blown into various shapes. As for example, glass. Glass is a one type of amorphous solid and we know that we can shape it in different type of designs. So mainly we will discuss about this difference between crystalline and amorphous solids. Then we will discuss about anisotropic nature of crystals. What is anisotropy and why crystals shows anisotropy. Then we will discuss about some difference between the properties of crystals and amorphous solids. So let us start with our first point, difference between amorphous and crystalline solids. So as mentioned, crystals have sharp melting point while amorphous solids do not have sharp melting points. Normally amorphous solids can be crystallized on heating at certain temperature depending on their natures. If we observe some ancient glass objects from structures or buildings, that means let us assume we have a temple which uses glass in their windows. So if we observe thickness of glass, then thickness of glass at the upper side will be comparatively less and thickness of glass at the bottom side of the window will be comparatively thicker. It is because of flow of glass particles. Because glass is amorphous solid and amorphous solids are also referred as pseudo-solid or supercooled glass. Now what it means? It means that they are actually not solid. Pseudo word represents it is not actually what it seems. So amorphous solids are also referred as pseudo-solids or supercooled glass because they are actually liquid and they are cooled at very low temperature. That means actually it is not a very low temperature, but for them as a liquid it is normal temperature is super low temperature. So that means amorphous solids are actually liquids which behaves as a solid. So if we observe glass from ancient civilization, then particle of glass will slowly flow at the bottom. After 100 or 200 or more than that years, some of the particles will flow down because of gravity, and that's why glass at the bottom will be thicker than the upper layer. So this is the nature of fluidic property of amorphous solids. Now let us talk about anisotropic nature of crystals. Now anisotropy, that means some of the properties gives different results from different directions for same type of crystal. That means if you are measuring some specific property from direction A, then it will give some different results than direction B. These type of properties are refractive index, electrical resistance, physical strength or mechanical strength, etc. Now let us try to understand anisotropic nature of crystal using this figure. So here we have a binary crystal. Binary, that means it consists of two different type of particles, particle A and particle B. So these two particles are arranged in a proper order in crystal. As you can see, they are properly arranged for a long order. Now let us assume we want to find a refractive index of this crystal. Now refractive index, that means ratio of light in a vacuum divided by light in medium. That means speed of light in vacuum divided by speed of light in a medium. As a medium we have crystal here. So when we try to pass light through different directions, it gives different results in crystal. Why? So let us understand using this figure. So as you can see in this figure, if light beam is passing through this direction, that means from left to right. In this case, only B type of particles come in contact with light. That means only effect of B particles will be seen. If you are passing light from top to bottom direction, in this case only particles of A will come in contact with light. That means only effect of A will be seen. Now let us assume we are passing light from bottom left to top right corner. In this case, both type of particles will come in contact of beam of light. That means mixed result of A and B will be seen on the speed of light. So because of this type of symmetrical arrangement, different direction gives different type of results in crystalline solids. So this is the reason of anisotropic nature of crystals. Now let us move on differences, different type of properties or difference between the properties of crystals and amorphous solids. So these type of properties are mentioned here, listed in table 1.1. So let us discuss them step by step. So as you can see, properties, first property, shape of crystal and amorphous solid. So as we know, arrangement of particles are systematic and regular in crystals. That's why they have definite shape, geometrical shape of arrangement of their constituent particles. On the other hand, amorphous solids have irregularity in them. That's why their shapes are irregular. Melting point. So crystals have sharp and characteristic melting point. That means whole crystal will melt. That means it will convert from solid to liquid at exact temperature. On the other hand, amorphous solids do not have fixed exact melting point. They will gradually soften over the range of temperature. As discussed in previous lecture, we observe that amorphous solids have irregularity in them. Some of the bond lengths are shorter, some of the bond lengths are longer. Some of the bond angles are bigger than some of the other bond angles. So that's why their bond strengths are different. So lower strengthened bond will dissociate first, while stronger bond will dissociate later. That's why it will gradually soften over the range of temperature and do not have specific melting point. On the other hand, crystals have exact melting points because all of their bond lengths and bond angles are same. Next property, it is cleavage property. That means when we try to cut our crystalline and amorphous solids with sharp edge tool like knife, then in crystal, new edge, that means surface of newly cut material or crystal will be smooth because of regularity in arrangement. On the other hand, when we cut amorphous solid with sharp edge tool like knife, it gives a rough surface because of irregularity of their particles, arrangement of their particles. Now heat of fusion. That means when we turn solid into liquid, it will absorb some of the energy. It is called heat of fusion. That means transformation of solid into liquid, and at that time absorbance of heat is called heat of fusion. So crystals have definite heat of fusion. That means they will turn into liquid at exact temperature. On the other hand, amorphous heat of fusion is indefinite, just like their melting points. Anisotropy. As we know, crystals are anisotropic and amorphous solids are not anisotropic in nature because amorphous solids have irregular arrangement of their constituent particle. Now let us assume we have a binary amorphous solid just like crystalline solid. But arrangement of constituent particles of amorphous solids are irregular, and that's why when we pass, let us say, light beam from that amorphous solid, almost both type of elements or constituent particles will come in contact with light because of irregularity in arrangement. That's why no matter which direction you choose, you will get almost same type of result, and that's why amorphous solids are not anisotropic in nature. Next property, nature. So crystals are true solids. They have all the characteristic properties of solids. On the other hand, amorphous solids are called pseudo-solid or supercooled liquid. because they are not actually solids but they behaves like a solid. That's why they are called pseudo solids. And supercooled liquid, that means they are actually liquids. As mentioned previously, glass of ancient buildings are thicker at the bottom side than the upper side because they shows fluidic nature just like liquids, but their fluidity is normally not seen because they are comparatively very viscous, and fluidic property of gases or amorphous solids are very low. That's why you cannot easily observe their fluidic nature. Last point, order of arrangement. As we know, crystals have long repetitive order of arrangement of their constituent particles, and amorphous solids have shorter order of their arrangement. So that means from these given properties, only anisotropy is irregularity of crystalline solids and it is regular in amorphous solid. That means mechanical strength, electrical resistance and refractive index like properties are irregular for crystalline solids. It gives different results from different directions. On the other hand, for amorphous solids, these type of properties give same type of results from different type of directions. So we can say that it is the only irregularity of crystals and regularity of amorphous solid. All the other properties shows a regularity in crystals and irregularity in amorphous solids. Now, if you have any confusion regarding to these topics or description, you can ask me about that, and we will try to understand that. And now we will meet in next lecture. Thank you.